Namaste, and a very warm welcome to our channel. I am your Java programming teacher, and today, we are diving deep into the fascinating world of Java Enterprise Edition JAX-RS representational state transfer services. This is an advanced topic, but do not worry. We will break it down into simple, easy to understand concepts. By the end of this tutorial, you will have a solid understanding of how to build robust and scalable representational state transferable web services using JAX-RS. We will cover the core annotations, how to handle different hypertext transfer protocol methods, manage parameters, and discuss some crucial best practices. So, grab your virtual pen and paper, and let us begin this exciting journey together. Alright, my dear students, let us start with the very foundation. What exactly are JAX-RS and representational state transfer services? On your whiteboard, you can see Java JAX-RS REST services written boldly. JAX-RS, which stands for Java Application Programming Interface for Representational State Transferable Web Services, is a Java programming interface that provides support for creating web services according to the representational state transfer architectural style. Representational state transfer, or representational state transfer, is an architectural style for networked applications. It defines a set of constraints for how web services communicate, focusing on statelessness, client-server separation, and a uniform interface. Think of it like a standardized language for different applications to talk to each other over the internet. It is all about resources, identified by uniform resource locators, and actions performed on these resources using standard hypertext transfer protocol methods like get, post, put, and delete. This makes web services highly scalable and interoperable. We will explore how JAX-RS simplifies implementing these concepts in Java. Are you ready for the next step? Now that we understand the what, let us see the how. Our second concept is building your first JAX-RS resource. Look at the whiteboard. We are defining our first service. We use the @path annotation at the class level to specify the base uniform resource locator for our resource, for example, myResource. This tells the JAX-RS runtime where to find your service. Then, inside this class, we define methods that respond to specific hypertext transfer protocol requests. For retrieving data, we use the @get annotation. The @produces annotation specifies the media type that the method can produce, like application JSON or text plain. Our example code shows a simple hello service class with @path, hello, and a method getHelloMessage annotated with @get and @produces text plain. This method simply returns a string. When a client sends an hypertext transfer protocol GET request to hello, this method will be invoked, and it will send back a plain text message. Simple, is it not? Excellent. Moving on to our third core concept, handling data with hypertext transfer protocol post, put, and delete methods, along with the @consumes annotation. While @get is for reading data, what about creating, updating, or deleting resources? The whiteboard now illustrates how we achieve this. For creating new resources, we use @post. For updating existing ones, we use @put. And as you might guess, @delete is for removing resources. When you send data to your service, you also need to tell JAX-RS what kind of data your method expects. This is where @consumes comes in, specifying the media type that the method can accept, such as application JSO or application XML. Our code snippet now shows methods like createResource with @post and @consumes, application JSO updateResource with @put and deleteResource with @delete. These annotations make it incredibly clear what each method is designed to do, adhering to the representational state transfer principles of using standard hypertext transfer protocol verbs for resource manipulation. Very powerful indeed. Let us put all this knowledge into a practical example, my friends. This is where everything comes together. On the whiteboard, you will see a more complete JAX-RS resource class. We have a product service class with @path products. Notice how we are using @pathparam to extract values from the uniform resource locator itself, for example, to get a specific product's identification number. For creating a product, our createProduct method uses @post and @consumes, application JSO expecting a product object in the request body. The getProductBid method uses @get and @pathparam ID to retrieve a product. Similarly, updateProduct uses @put and deleteProduct uses @delete, both leveraging @pathparam for identification. This example demonstrates a complete create, read, update, delete set of operations for a product resource. Remember, clarity in your uniform resource locator design and method annotations is key for maintaining a clean and understandable representational state transferful application programming interface. Take your time to study this code. It is a blueprint for many real-world applications. Alright, my dear students, let us talk about common mistakes and some best practices to ensure your JAX-RS services are robust and efficient. On the whiteboard, we have two columns, common mistakes and best practices. A common mistake is forgetting to expand acronyms like JAX-RS or representational state transfer. Always write the full form, especially when teaching or documenting. Another mistake is incorrect media type handling. If your @consumes and @produces do not match what the client sends or expects, you will face errors. Always ensure your media types are consistent. For best practices, always design clear and intuitive uniform resource locators. For example, products ID is better than getProduct ID is equal to ID. Implement proper error handling using JAX-RS's response object to send meaningful error codes and messages. Always strive for statelessness in your services. Each request should contain all the information needed to process it, making your service scalable. And finally, remember security. Always validate input and consider authentication and authorization for production-grade services. Following these guidelines will save you a lot of headache.